speaker last year here at Craft Conference. And actually, Kevlin, the stage is yours.
All right, good afternoon. I have the difficult task of keeping you awake because you've just had lunch. And there were a lot of carbohydrates in that lunch. So let's see if I can do that. But if you want to have a sleep, there's some really comfortable spaces back there and to the side. So this is what we're going to talk about for the next 45 minutes. I'm not really going to take questions on this, not because I don't think there are questions, but because those questions I think are much better served in a conversation. I'm around all day and all of tomorrow, so I would much rather have a personal conversation about these things. It's not a case of, Kevlin, how do I use this technology in this context? I have this problem. That's not really what this is about. So, metaphors we code by. I'll explain the origin of that title in a moment. My name's Kevlin Henney. I'm an independent consultant and trainer from the UK. I also have a fairly internet-unique name, which used to be fairly easy because you just put your Twitter handle up. But these days, things have got more complex. So I have a bunch of other social details if you want to get in touch with me. Also, good places to ask questions. And I was in a taxi this morning and discussing with Joseph Pellerine about a talk that I did over a decade ago, a keynote. And somebody, Steve Freeman, who I'll quote later in the talk, had made the observation that said, with Kevlin, you just give him, he picks a word, and then he'll just do a 45-minute talk on it, and he'll just go deep into it. So yes, that's exactly what you're going to get. But today, actually, I give you better value for money. I'm not just going to pick one word. I'm going to pick a few words. Because what I want to explore is the fact that software is what I would consider, it's not kickable stuff. Just to clarify, there's no translation issues. When I say that something is kickable, I mean kickable, yeah? As in I can kick it. Software is not kickable. Much as sometimes you want it to be kickable, it's not physical. It's an abstract concept. How do we talk about it? How do we think about it? Our use of metaphor is extensive and deep to the point we don't even see it. So the word metaphor comes from the Greek, metaphora. It means transfer. It's actually that simple. The idea of transferring one idea to another. In fact, this morning, Sam, in his keynote, referred to the Oxford English Dictionary. And that is also something that I have. It's one of the few pieces of software, rather than dealing with just the subscription, I actually have some software that I install on my laptops. I like dictionaries. I have lots of physical dictionaries, and I also have dictionaries on CD-ROM. It's the only thing I have on CD-ROM that I still use. And the OED, just to clarify, the OED is not a useful dictionary if you are trying to look up a word to understand how it is used. It is not a usage dictionary. It is a historical dictionary, an etymological dictionary. It will tell you about the words over the last 1,000 years. And if that turns you on, this is your dictionary. If that doesn't, you don't want this. The figure of speech in which a name or descriptive term is transferred to some object different from, but analogous to that to which it is properly applicable. We describe something in terms of something else, understanding that such a description is an analog. It's not the same, it is a parallel. We understand that it is not perfect. So whenever anybody says, that's not a perfect metaphor, well, yes, that's the whole point. It's a metaphor. Yeah? If it's a perfect metaphor, then it's identity. It is the thing. So there will be no such thing as a perfect metaphor. My title is a riff on this book, which was published in 1980, Metaphors We Live by George Lakoff and Mark Johnson. Now, there's a lot of other stuff that's been published since. I'm not going to pretend that I am an expert in this space, but this book is a magnificent starting point, highly influential, perhaps a little academic in style, but it is kind of one of the key observations, and it kind of set our thinking. I also like the fact that when you look at the book cover, it really looks like it was published in 1980. Okay, people don't do book covers like this anymore. I actually have a kind of thought about carbon dating books just by looking at their fonts and their typeface choice and their color choice. And you can actually do it pretty well. Metaphor is pervasive in everyday life, not just in language, but in thought and action. What was interesting about this book when it came along is that most of the time when people learn about metaphor, they learn it in school. And they're told about metaphor in poetry. They're told about the use of metaphor in Shakespeare. In other words, we tend to be taught metaphor as a special thing that happens over here in writing and in arts, but not a thing that is actually every day. The whole point that they make is no, it informs everything that we do. The essence of metaphor is understanding and experiencing one kind of thing in terms of another. Notice there's a difference here from the OED definition. I like that. Experiencing something. Not merely describing it, but experiencing it. That's much, much deeper. And they describe a number of systems of metaphor, highlighting these in the book. And you can start seeing how this works. The metaphor of argument is war. What does that mean? What it means is that it tells us how we're going to talk about it. Argument is war. That suggests that I'm going to use terminology and language that is to be found in warfare. For example, he attacked her position. Attack, that's the language of war. She defeated his argument. Defeat. This is the language of combat and war. So in other words, within a kind of metaphorical frame, it tells you the words you're going to use. That is immensely powerful, particularly when it comes to things that are abstract. What is an argument? It's a very abstract idea. This is one that seems to pervade Western culture, and particularly the English-speaking world. Time is money. How do you spend your time? Okay? Spending. That's the language of money. Okay? People talk about saving time. Yeah, we save money as well. Oh, well, other people save money. I'm not very good at that. Happy is up, sad is down. I mean, literally, people will say, I am feeling down. Now, of course, there's another thing here as well. These are not universal. These are tied to language and culture. Okay? The use of the vertical direction is very particular, but it's not universal. People have different ways. They have left, right, front, back metaphors depending on language and culture. But once you are in that frame, that gives you a whole vocabulary. Because if I'm feeling down, then obviously the opposite of that is up. Yeah? If I happen to be in a language where left is feeling happy, then obviously going right is the opposite. In other words, you generate a system of thinking, a system of description. Love is a journey. Where is this relationship going? Okay? Going is a thing that you do in the real world. It involves displacement with respect to time, velocity. So the idea is that you have these words and concepts. And sometimes you can have multiple metaphorical frames applying to one idea. Arguments are buildings. What does that mean? Well, you know, her argument collapsed. Collapse is the language of structure. It's not the language of war. His argument had no foundation. Foundation, you find those in buildings. So you see that they are everywhere. This is not Shakespeare. This is not poetry. This is ordinary language. We use it all the way through. And one of the things that can be very challenging when you learn another natural language is to learn its appropriate metaphors. And we find, this observation has been made time and time again. This book was published in 2008. Andy Hunt, Pragmatic Thinking and Learning, he talks about metaphor. And what we call windows on the computer screen aren't really windows at all. But think about it. You have windows on your desktop. That's kind of crazy. That doesn't make sense in the real world, but we understand what it means. But what do you do with windows? You can open them and you can close them. The language, you don't start a window. You don't run a window. You open it. Okay? You close it. Of course, these are not perfect, because you also resize windows. I don't know if you've ever resized a window. We've done it in our house. It's surprisingly expensive. And our windows don't have buttons, but there's the idea there. A folder on your hard disk isn't a real folder, and the trash can isn't a real can. In fact, there's an interesting thing going on here, is that sometimes a metaphor will capture a particular world or point of view. There's a bias here. The bias here is that Andy uses a Mac. I don't use a Mac. I use Windows machines. Okay? Windows has a recycle bin. Why does Windows have a recycle bin? Because they wanted to avoid the term trash can? No. Because the Mac was developed in the 1980s. Windows with the recycle bin arrived in 95. In 1980s, recycling was not a thing. So that's a snapshot. In the Apple universe, you throw things away. But it turns out that you can just pick them out of the bin and use them again. Recycling. We capture a point in time. You may find that with other words. They capture points in time. When you write a concurrent program using threads, you're not sewing. Although sometimes it does feel like that. Well, at least you kind of seem to stab your fingers a lot. It's just a metaphor. We can start this with computer. So this was one I was thinking about this morning, and I chatted with Joseph about it. It's just like, yeah, I've got a photograph. So this is an interesting one. This is taken in the late 1940s. It's the Colossus. And the question is, can you find the computer? Well, there are 3 computers on the screen. There's a computer on the left, a computer on the right, and then there's a computer in the middle. Computer was originally the description of a person who does computation. And then there was a transition period where we had people who did computation who worked with automated machines that did computation. We then called automatic or electronic computers. And now we forget that computer actually referred to a human role. We use the term memory. They're interacting with memory. Memory is like this. But the funny thing about memory is that this word has now become so embedded and pervasive that actually we use it differently. Okay? When we talk about memory, we no longer confuse that idea or even have that idea informed by the real world. We actually use the language differently. So when I'm talking about coding, I might say, oh yeah, the object is in memory. You would never use that as an English sentence to describe your own memory. You don't talk about things being in memory. You talk about remembering things. But we don't tend to, in English, talk about, oh yeah, it'll remember it. No, you say it's in memory. We actually have, the language has actually forked in that sense. It becomes distinct. It takes on a life of its own, just as all these other words often do. It takes on a life of its own, and we forget that it was a metaphor. Here's one that seems to be very popular at the moment. This one has not yet managed to, well, we don't have a good definition of it for the real world. So when we talk about artificial stuff, we are doubly challenged. So obviously this is the gratuitous and necessary ChatGPT moment. I thought I'd have a little conversation with ChatGPT. Are you intelligent? As an AI language model, I can provide information and generate response. Notice the clever way in which it avoids answering the question. This is a yes-no question. It doesn't even acknowledge that. It answers like a politician. We have created artificial politics. Awesome. I'm not sure we needed any more politics, but there we go. I can provide information and generate responses on the data I have been trained on. I don't possess personal experiences or consciousness like humans do. Notice it is bringing a number of other things in by implication. The intelligence metaphor has that. As a metaphor, we use the word, but it brings in. When you and I talk about intelligence, we have a number of subtle implications, such as experience and awareness. So the data sets have clearly got that. However, I can assist with a wide range of tasks. This is the marketing bit. Okay? It's not a sponsored message here, but it is a marketing bit. I can and provide useful information on various topics. My capabilities are a result of the training I have received and I don't have true understanding or consciousness, but I do respond in the first person to make it feel like I'm a person. That's kind of interesting. just as an interesting aside, that phrase, you start seeing that in a lot of places. That one's not just been trained in, that one's very much a part, as an AI language model, is all over the place now. But you know, I like to think that I'm fair and I want to have a balanced conversation. So my next question was, am I intelligent? I had no idea what to expect at this point. I mean, you know, I know what would happen with a human being. There'd be a joke, or there'd be, oh, I don't feel qualified. Well, you know, you seem pretty smart to me, Kevlin, or, well, I don't know, you've done some dumb things. That would be my friends, my wife, my kids. Intelligence is a complex and multifaceted trait. Good way of avoiding the answer. Well done, ChatGPT. And it can be challenging to define and measure it accurately. So in other words, it's actually answering a different question. It's answering the question of what is intelligence. It's not answering the question, am I intelligent? Which is kind of a good, safe bet. So it's being polite at this point. Adapting to new situations. Again, we're actually learning about what the word entails. The idea, I'm using the word intelligence, but actually it comes with a cloud of possible meanings associated with it. Notice that. Reasoning, learning, adapting to new situation. As a human, you possess a level of intelligence, good use of the second person. This paragraph is the flattery paragraph. It's to make me feel good. You possess a level of intelligence that allows you to think, reason, learn, and interact with the world. I feel good now. Humans have the capacity for self-awareness, consciousness, all these other things that are implied. Your unique combination of skills, knowledge, and experiences contributes to your individual intelligence. Thank you, ChatGPT. That is going on my CV. My unique combinations, yeah, there you go. It's important to recognize intelligence is not fixed, and now there's another marketing message, and another feel-good message. Okay, so I wrote about this when talking about AI. I wrote a thing on scaling AI last year for O'Reilly Radar. While the brain is one of the most power-hungry organs of the human body, it still has a modest power consumption of around 12 watts. So just to give you a kind of sense, running this is surprisingly cheap. Okay, it's a really carbon-friendly thing. It doesn't take much power. It is less than a traditional light bulb and only marginally more than an energy-saving bulb. You're not expensive to run, okay? I say that to all the new parents here who are busy spending lots of money on their kids, going, wow, kids are really expensive. But it turns out this bit's not that expensive to run. It's everything else that's hard to run. Over a life, the brain will consume up to 10 megawatt hours. That's your total brain power consumption over a lifetime. GPT-3 language model took an estimated 1 gigawatt hour. That's kind of interesting, because what we've just discovered here is we've been talking about intelligence and stuff. That's surprisingly expensive. One of the things that we know from an evolutionary perspective is that intelligence can't be too expensive, otherwise you don't actually have a viable life form. And that here is where we are reminded again of the difference between the physical and the abstract. Ultimately, when we create software, we are going to hit the physics at some point. And that's a really good example. So in this book on patterns that I co-authored a number of years ago, we talked about a number of concepts. We talked about certainly patterns, architecture, design, how people think about and reason about their code. We talked about, referring to Sam this morning, we talked about semiotics. We had a whole load of fun with this book. This book is, I would love to say, sometimes people ask me, should I get this book if I'm interested in design patterns? No. This is the book that you read after the book that you read because you were interested in design patterns. This is the book that you read if you're very, very interested and we've not been able to scare you off yet. This should stop you. But it was fun to write. The whole idea is, here's all our thinking. Made the observation, the aphysical and invisible domain of software is more about metaphor than matter. We do not really deal with the physics a lot. We name things and organize our thoughts in this sense. And we use metaphors without realizing we're doing that. And for me, this was an interesting one because I realized many years ago that, and it was many years ago, that on the software that I was working on, there were at least 3 different things called network. And it caused me, I paused for a moment, I thought, network, that's funny, because we've got network in our code because of a TCP/IP network. We wrote the middleware layer. We have got network in our code because it's a mathematical abstraction. It's a graph structure. We've also got the word network in our code because the domain of the application is managing an electricity network. In other words, the word network occurred in 3 different places with 3 different entailments. Network in English is just an old word for net, what you catch fish in. But nobody uses that word anymore. So this kind of fascination led me and Andy Longshaw a number of years ago to run a couple of workshops. We ran one at the European Pattern Languages of Programming Conference in 2006. See, people doing work, workshopping, fantastic. We published a paper on this, Metaphor in Software Development, where we kind of explored the output of this. We ran the same workshop, similar workshop the year after, the Software Practice Advancement Conference, so in 2007 in Oxford. And we looked at a number of different cases. So let's start within the code base. There's an observation from Donald Knuth. He said trees sprout up just about everywhere in computer science. That's a tree. But there's something wrong with this tree. Oh, there we go. That's right. Good. Our trees are upside down, and we don't even blink. It was only when I was explaining it to my young son actually it was my older son a few years ago, I was explaining to him, oh yeah, there's a tree here. What do you mean tree, Dad? Oh, in software we use the term tree a lot. But there's a couple of differences, you know, the root's at the top, the leaves are at the end, and my son is just looking at me, and he can't work out whether I'm joking or not. You know, Dad, is this one of your stories? Are you making this up? No, really. And it's at that point you suddenly realize we are a whole discipline that is quite happy to talk about upside-down trees as if there's nothing wrong with that at all. And everybody else in the world is going, that's a little bit strange. Stay away from the software developers. They don't think right. But here's the point. It will never map its target perfectly. A metaphor is a conceit, not an identity. It is a way of thinking. It is not the thing itself. It is a descriptive structure. Beautiful quote from Tony Hoare. You cannot teach beginners top-down programming because they do not know which end is up. So in the real world, we tend to think of trees as being green. I've just shown you a black and white picture. Do we have colors for our trees in code? Does that make sense? Well, yeah. We have red-black trees, if you remember your computer science, your data structures and algorithms course. They're also, you know, there's much humor to be had on this one, XKCD. It's a Christmas tree with a heap of presents underneath. Yeah, it's funny, trust me. But here's the point. In everything that I've just done, notice the language. If I say it's a tree, then it's like I get a whole load of free words that I get to use with it, and they fit within. They are a description there. So this is this idea of metaphorical entailment. Entailment's probably not a common English word, but it's the suggestive nature of something. Metaphorical entailments can characterize a coherent system of metaphorical concepts and a corresponding coherent system of metaphorical expressions for those concepts. You're not just describing a thing directly. You've got a word cloud, you've got a meaning cloud around it, and you're saying some of this meaning cloud also translates, and we will use vocabulary from that. Now, you've had lunch, so you shouldn't be salivating at this point, although actually that's really quite a nice stack of pancakes, which is, yes, exactly, that's what we're going to talk about, stacks. The most overspecified data structure in the history of computer science. So let's talk about stacks. If I use a stack, that's a stack of pancakes. Stack. How do we talk about it? Well, I could talk about the size of the stack. So size, that makes sense. Because it's discrete, count might also make sense. Okay, so if I'm working in Java, then perhaps having a stack with a size makes sense. If I'm working in .NET, having count makes sense. What about the word length? You know, that doesn't make sense. Because length is a horizontal concept. I've just shown you a vertical thing. Okay, a queue is a horizontal concept, and it has a length. Yeah, you go and stand in a queue. A queue is described as being long. I'm from Britain, we're really good at queuing. We can form a queue of one if necessary. But queues have length. It's a short queue, it's a long queue. It's not a vertical description. Stacks are vertically oriented. It doesn't make sense to talk about the length of a stack. That's just bad English. So perhaps other words we might use are height or depth. These have vertical suggestion. And how do we talk about the top of a stack? Well, top. Some languages and libraries have the word top as the way to describe the top. Honestly, that really is the simplest name. Some, for bizarre reasons, use peek. Peek is to take a quick look at something. That doesn't make sense. That doesn't fit with the metaphor. It's as if you're doing something naughty. Well, I know I shouldn't do, but let's have a peek. There's nothing naughty about looking at the top of a stack, because it's supposed to be a thing you can look at the top of. I guess there is also a kind of play on words we could use that's definitely a no, which is peak. Peak is the top of a mountain, but we're definitely rejecting that one. And then possibly the worst is this one. Get top. This morning, Sam asked which word in the OED, which word in the Oxford English Dictionary had the most definitions. In the existing version, it's set. The next version, it's run. But which word is in the next place? It's get. Get has hundreds of definitions. Get is, let me just clarify, if you're putting get in front of your method names, I'm going to clarify some English for you. Get does not mean ask a question. It does not mean make a query. In English, get means change the state of. Okay? If you get something, you change the state of it. When you get the top, you remove it. When you get married, you change your marital status. When you get money from an ATM, you change your bank balance and the balance of the ATM. Get means change this with the side effect. That's what it means. So I'm hoping to discourage people from using getters in their naming convention. It was always a bad convention, but the fact that it doesn't actually work with English is kind of a big giveaway. Get top doesn't make sense. So yeah, that's a big no from me. Pop. That's the word that we use for getting the top. Push. These are literally called push-down stacks. Of course, this takes us into naming. It's not perfect. You're never going to come up with a perfect set of names. But the whole idea is to create a system of names. You need to have a system of naming. And that doesn't always work the first time. You need a process for this. Commit strip has a rather good one on this. You've got your developers at a company. Data, too generic. Interestingly enough, somebody I know actually did this. They went and checked. So Peter Hilton went and checked GitHub a few years ago to find out what the most common name for a variable was that had more than one letter. Because if it's one letter, it's probably I. Okay? And what he found was data. And the second most popular was data2. Come on, people, we can do better than this. Data, too generic. DataDB, unclear. Let's say list completed, already used. Array list data completed, that nah. We must choose now or the client might cancel the project. Well, array list completed form without duplicate, too long. Unable to name a variable, they go bust. I suspect that might never happen, but I do want to point out that this is not unreasonable to spend a bit of time, because you're not merely labeling something. When you are naming things, whether you are naming a class or a variable, whether you are naming an interface or a whole subsystem, what you're doing is you are not simply labeling something, you are trying to transfer a system of thought into somebody else's head. That's not necessarily that easy. That's why we care about iteration. We often don't get things right the first time. We move with convergence towards things. But we did have an interesting observation that came out of the workshops. There was a general consensus in the focus group that metaphors could be highly expressive, but to actively seek them might be too forced or the result too contrived. Sometimes people push this too hard. In other words, we need a metaphor, and they'll sit around coming up with the metaphor. And it's often before you've truly understood the idea. Now, this was actually interesting enough. Metaphor its status was elevated significantly in the space of XP, extreme programming. In the original XP, there were 12 practices. One of them was metaphor. And Kent was really big on the idea, although kind of dialed it down over the years, but he found some really good metaphors for some systems. The problem is they were very selective. System metaphor was always the first practice with XP teams that they would drop. Because trying to find the right metaphor is a bit like saying up front, we must have the right architecture at the beginning. You know what? It's not going to happen. You need to iterate towards it. If you push too hard, you will end up with a very strange system. So one of the observations, we need to evaluate what we mean by a good metaphor. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. So I wrote this piece on technical debt a couple of years back, and one of the things I did was explore metaphor. And I was thinking, like, what is a good metaphor? We use the word good a lot. Good is not the end of a conversation, it's the beginning of a conversation. What do I mean by that? Well, just imagine sitting around. Let's talk about the qualities in code. I want you to imagine sitting around. You're at the kickoff for the next major release. You're with your team. And somebody says, what kind of code should we be aiming for in the next, in the next release period? One of your colleagues says, I've got an idea. I think we should write good code. What an excellent suggestion. Okay, so how should we do our tests? Oh, I think we should have good tests. Brilliant, this is going so well. What about our architecture? I think we should have a good architecture. Excellent, we'll do that one. Do we have any approaches to naming? They should be good. Oh, this meeting is going so well. It's good. Good is just a placeholder, but you have to have something in its place. You have to say, well, when I say good, I mean. So let's talk about what do we mean when we have a good metaphor. How do we evaluate a good metaphor? It has to offer a number of points of useful correspondence. In other words, it's not just it has a few points of correspondence. They have to be useful. They have to help you. They have to be something that you can use in language that conveys what you're talking about. They also should not have too many obvious points or points of obvious conflict. In other words, because we know that metaphors are never going to be perfect, they will disagree. There will be places like resizing a window where it doesn't really make sense. And that's fine. It just should not be the most obvious thing. If the basis of your metaphor is fundamentally in contradiction with the thing that you're trying to work with, that's not going to be very helpful. So there will be conflict, but it should not be too obvious or too often. The third one, this is a really interesting one. It's the one that people most often overlook. Familiarity. We're talking about language here. So familiarity is really important. So let's understand. I've got an abstract concept that is difficult to describe, and perhaps you don't understand my thinking on a piece of code. It's a difficult concept. So what am I going to do? I'm going to try and describe it in terms of another concept. There's a kind of mapping here. If you don't know this concept, that's not a very good mapping. If I have to explain the basis of this mapping using another construct, we have a problem. Too many levels of indirection. So sometimes people say, oh, I've got the perfect metaphor, and then you go, I have no idea what you just said. It has no meaning to me. So it's not the perfect metaphor, at least not for me. It matters to your audience. Your audience will also influence the metaphor. So, yeah, let's talk about Stonehenge. No, let's talk about legacy systems. Let's talk about how do we deal with stuff that is old, or talking about stuff that we don't particularly like working on. We might use the term spaghetti code. Spaghetti code comes to us from the 60s and 70s. Is this a useful metaphor? Not really. I like spaghetti. If somebody says, hey, we've got spaghetti code, fantastic. What kind of sauce have you got to go with it? I love spaghetti. Okay. It's a suggestion about the control flow, but it's not a suggestion about the quality. It's not a suggestion about personal preference. But you will also see that sometimes people then run with the pasta family. And although spaghetti code is considered bad, people will then suggest maybe lasagna because we want a layered architecture. Or perhaps ravioli. And what I love is the ravioli metaphor has been around for decades, and each generation rediscovers it. I recently saw somebody saying, oh yeah, ravioli, that's microservices. Jump in the time machine, go back a few years. Ravioli, that's services. Funny, I remember services being smaller than modern microservices. Perhaps my understanding of the word micro is incorrect. You go back another 10 years, ravioli was components. Another 10 years before that, ravioli was objects. Okay, so call me back in 10 years, we'll see what we're talking about, but there will be ravioli involved. But it's not a good metaphor, the pasta thing. It's fun, but it's not helpful. Code rot, software decay. These are very suggestive. But there's a problem here, is they involve a natural process. And if I leave a piece of code alone, it doesn't rot or decay. Yeah? Whereas if I leave some yogurt in the fridge for too long, it does rot and decay. It doesn't involve any participation from me. Code does not decay. If you leave it, it just stays as it is. Of course, the rest of the world might move on, so that it becomes legacy through that reason, but it doesn't itself rot or decay. So it's suggestive, but there's a kind of a real issue here about process. There's a suggestion of process, but it's not quite right. I always used to love entropy as a description. And that was one that I was really keen on in the early 1990s. There's a small problem with it. I have a physics degree. Most of the people at the company that I worked in also had physics degrees. Entropy, yeah, I can give you equations. It turns out that not everybody has a physics degree. Who knew? It turns out it's not that helpful because then you have to explain what entropy is. So, yeah. Technical debt. Oh, we're going to talk about that one. Surprisingly popular, very powerful. Unhedged call option. I might talk about that one. Housework. Oh, that's interesting. So, let's talk about the word legacy for a moment as well. It's actually quite young in terms of the context of technology. 1989, which is roughly when I entered the workforce. I regard that as a coincidence, not a causal relationship. I mean, people had legacy code before it, they just didn't have language to talk about it. But the default meaning of legacy is much more positive than the one we give it in a software context. There's a whole talk on the word legacy. I have done that in the past. We're not going to spend time on this. I'm just going to kind of focus on that for a moment and go to technical debt. This is by far and away the most common way that people talk about the problems that they have in their code structure. It originated with Ward Cunningham, but Ward kind of coined the debt metaphor in 1992. But it was really popularized by Martin in the early 2000s. Some of us were using debt as a metaphor. But it wasn't necessarily in the 1990s called technical debt. Ward never used that term. People use different terms. They use technical debt, quality debt, design debt. There were lots of different words around. But Martin's original blog, and he's since updated it, sadly, which is a historical document. You can still kind of dig through it and find it on the Wayback Machine. But he makes the observation, technical debt is a wonderful metaphor developed by Ward Cunningham. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. Now notice, it's similar to, it is not a financial debt. It's very careful with his wording here, because I see teams actually trying to quantify their technical debt as a financial value. That does not work. That is just bad science. It's a metaphor. You're not actually supposed to put the numbers into an equation and say, this is how much financial debt we have in our code. If you do get a number, that is just pure fiction. It has no bearing on the actual relationship between your code base and debt. It's a number that might make you feel good, but it's a bit chat GPT. It's just a complete lie. Okay? It's just telling you bullshit to make you feel happy. So be very careful. It's a metaphor. But there is a problem here, and the problem is set up here. Martin repeatedly uses, in his article, in his blog piece, he repeatedly uses the phrase quick and dirty. Quick and dirty. And this quick and dirty is not a positive thing. It's kind of a quick fix. It's a workaround. It's not something that's not necessarily good. And it's intentionally not good, but not in a way that we would praise. This actually has some interesting follow-on, that and a few other things, that people tend to think of technical debt as a bad thing. I have some interesting news for you. It's not. That's not the intention. I mean, there's a lot of debt that is bad, but technical debt is not itself bad, according to the original intention of the metaphor. The idea is that if you manage your debt, it's all good. The whole point of the debt metaphor, if we actually go to what Ward said, shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. What Ward was trying to say is that you're using debt as a trade-off. Debt is a borrowing. That's the whole idea. You're borrowing against yourself, against your future. The whole implication of the debt metaphor is you pay it back. So when people say we have a technical debt problem, what they actually mean is they have a repayment problem. Debt is not the problem. Repayment is the problem. If they don't manage their debt, they have a problem. So in other words, it's unmanaged technical debt is your problem, not technical debt, unmanaged technical debt. Now that might be 100% of your debt, but I just want to make sure we get the words right. And Ward warned us about this. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. That's the whole point. The interest rises. Therefore, you have a financial instrument that is going to cost you more over time. This is the key idea. And this is a really important idea because I've had the conversation with people in the real world, on Twitter and elsewhere, where they've said, oh yeah, we've quantified our debt in our code, and perhaps they've said not in terms of money, but in terms of time. How much would it take us to address the technical debt? So their debt is measured in hours or days or years. But that's not the debt. That's a misunderstanding of the basis of the metaphor. It's not the cost of repayment, it is the cost of owning the debt. And that, as I say, that's not the same. The whole point, it's not the specific word needed to repay it. It's all of the additional time and effort you've had to put into the past, the present, and the future. That's the cost of owning the debt. It's not one repayment. It's not a major repayment. It's the overall cost. That's the implication. That's what Ward was suggesting. Steve Freeman likes this as a metaphor. And I'm not going to argue with it, except to say that in order to understand this metaphor, and this is one of those things I regard it as not an effective metaphor, because most people don't know what an unhedged call option is. If you work in banking and trading and investment banking, you will know what this is. But if you don't, then I have to now explain what one of these is in order for you to understand. No, this is a failed metaphor in that sense, outside a very particular audience. I quite like this one from Yvonne Lan a couple of years ago. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt, but we can't use it because tech has been made up of people who don't do housework or manage housework being done. So here's a thought. Although a metaphor may successfully capture some, or a part of the aspect, coverage of most concepts is improved through multiple metaphors. It is natural for us to mix our metaphors. That's the normal thing. We don't find one unifying metaphor for our whole code base, for our whole architecture. We mix and match, just as we do when we speak. We worked with mixed metaphors. Just a final word on technical debt. The problem I've been kind of addressing recently, or rather trying to get people to focus on, is when we think about it, people have been looking at technical debt, let's just say unmanaged technical debt, as the effect. If you're trying to solve a problem, you don't just solve the effect, you need to solve the cause. You need to understand, where did the debt come from? People don't answer this question. I've had so many workshops where we've talked about legacy code, and everybody says, how do we address our legacy code? And they're interested in fixing the problems they have. The question they never ask is, and how do we stop creating legacy code? Because there's no point in fixing the result if you don't fix the cause. If your boat is sinking and there is a hole and you have a bucket, you have two things you need to worry about. One, get water out. Two, plug the hole. Otherwise, you will be getting water out for the rest of your career. This is the metaphor that we want. It's neglect. This is the cause. How do we end up with stuff that is unmanaged? Because we've neglected it. In the real world, we have physical neglect, emotional neglect. I'm going to introduce a term, technical neglect. If you think you have a technical debt problem, actually, you probably have a technical neglect problem. That's the real thing. Go and look at that. So, the point here is, although we use metaphor, you kind of got to keep it real. You have to remember that ultimately, we develop software, we are human beings, we live in a physical world, our software runs on physical platforms. We work in companies that are made up of physical stuff and biological stuff. Our metaphors are a way of expressing our thoughts to one another. Our code is communication. Our documents are communication. Sometimes our communication, it's not communication, but a reminder, communication, the word communication comes from the Latin communis, means together. You're trying to get everybody together. That's what we're trying to do. And that's a reality-based thing. Don't get lost in the metaphor. Don't take it too seriously. But I will leave you with one final word. Pataphor. A pataphor is one step beyond a metaphor. It's an extended metaphor where you start referring to an original metaphor as if it were actually real. So it's two levels removed. As software developers, you fully understand levels of indirection. In other words, you end up building a metaphor within a metaphor. And of course, this does indeed relate to software development. There's this wonderful quote from Maya Manny Lehman back in 1980. And I think this is the best sentence in this paper, which is a great read, but I love this. And by the way, this is how you will introduce yourself next time somebody asks you, so what is it exactly you do as a software developer? Well, any program is a model of a model within a theory of a model of an abstraction of some portion of the world or of some universe of discourse. That should shut them up, and they won't ask you to fix their computer. Thank you very much.